Sean, thank you very much for joining us.
Thanks for having me.
Okay, so tell us about your background. How is it that you got to where you are today?
Thanks for the question. So I started out in emergency management as an offshoot of my time on active duty military when I was in the Navy.
Mm-hmm.
At the time, the United States military, after 9/11, was going on the journey of upgrading their emergency management programs at the installation level. So from a base to base, Navy, Marine Corps, all the services were updating and integrating a new emergency management program. At the time, that's where I became interested. I then left active duty and had an opportunity to join federal service with the National Institutes of Health. And because of that experience that I gained in the Navy with their new emergency management program, I decided to join the Office of Emergency Management at the National Institutes of Health as an emergency management specialist. That was about 11 years ago now. And then I spent 2 years at NIH, responsible for the campus there, everything from the medical facility to animal facilities to biosafety level 3 laboratories, et cetera. And then moved to Defense Logistics Agency, was the emergency management director there for the headquarters at Defense Logistics Agency. Then went to the State Department, also in the Office of Emergency Management. From there, I worked on a number of White House committees. The gentleman who chaired one of those committees went to the Department of Energy. He asked me to join him there, so I went to the Department of Energy as an emergency manager. And then I was detailed during my time at DOE to the White House National Security Council, as you mentioned, Director for Incident Management Policy. Actually, the same position that Tom Roston, the gentleman who brought me over to DOE, had.
Right.
So I was relatively familiar with the portfolio. After my time at the White House under President Obama and President Trump, I left March of 2017, went back to the Department of Energy, and they didn't really know what to do with me. So I worked on a number of projects to include an exercise that we ran down in Texas, Houston, Texas, modeled after Hurricane Ike, similar hazard characterization as Hurricane Ike. And then, as you know, we had Hurricane Harvey that year. So the exercise was in May. We had the event in August. And it was a new administration and a different administration. It's one where at the latter end of 8 years of presidency with respect to President Obama, the wheels are well underway. The greases are skids, or the skids are greased, so to speak. Mm-hmm. And folks really understand what they're doing. Well, with the new administration, you have folks that were just put into place. Brock Long, who is a professional, a great emergency manager, he was on the job for 2 months when Hurricane Harvey hit. Jeff Byard, who is now the administrator who has been nominated, it was his second day after Hurricane Irma.
Wow.
So
by fire.
Right. So these individuals, great men and women who decided to serve in these positions, but they're new, and it doesn't matter how many years of experience. It's still a new position. You have to get acclimated. Mm-hmm. You also have to wrap yourself into the environment. Jeff Byard came from Alabama, which is where he knew Brock Long. Mm-hmm. He was, I believe, the operations director there. And he's just trying to understand the federal system, which is very complicated. And we talked about this previously on our last call, is that the challenge is all these laws and all these regulations, it's very difficult to navigate. And one of the things that was very illuminating during my time on the National Security Council staff is that I was asked to put together this transition exercise. And so the Presidential Transition Act of 2015, Congress said it's a good idea to train the folks who are incoming, whether it was the Clinton team or the Trump team. It doesn't really matter. This is about America and our national security and our homeland security. And so what we did is, based on that legal requirement, we put together the incoming team with the outgoing team, and we trained them on 4 different scenarios. But really, we didn't train them on the scenario. We trained them on the legal aspects of their job. If they were the Secretary of Energy or the Secretary of State or the Secretary of Homeland Security, here are the key authorities, regulations that you need to know, Mr. or Mrs. Secretary, incoming Secretary, on how to perform your duties. Because a lot of folks forget or maybe overlook the fact that on January 20th at 12 p.m. Eastern Standard Time, all of those officials become a pumpkin, like the Cinderella story. They are no longer have any legal authority. And all of those incoming professionals, whether it's Rick Perry with respect to Secretary of Energy, he's not confirmed yet. And I believe he was confirmed March of 2017. So, a few months later. So you have this vacuum, or really this institutional knowledge that left. And so that's what made me more appreciate the understanding of things such as interdependencies, not just with respect to physical infrastructure, because a lot of people like to talk about the interdependencies of power systems and communication systems and how a failure of one can impact the other. And that's pretty well understood. But I think what's less understood is the interdependent nature of the legal systems, not just here in the United States, but internationally. What we had talked about is how does the United States onboard, say, urban search and rescue teams that have dogs and medicine and licensed professionals that aren't necessarily accepted here in the United States, and given our federalist system, that the states are the ones who credential medical doctors and paramedics and EMTs and firefighters and so forth. And Customs and Border Patrol deal with the imports of medicines and so forth. And so we have this overly complex system. And what became very evident to Brock Long and to Jeff Byard and to Dan Kanuski and to all these individuals who are seasoned professionals, these aren't rookies.
No, not at all.
No, they're not. It's overly complex. And I give them a lot of credit, because if you look at FEMA's the Federal Emergency Management Agency's 3 strategic objectives, it's build a culture of preparedness, ready the nation for catastrophic disasters, and reduce the complexity.
Yeah.
The reduction of complexity is focused on FEMA, but really it's the entire system in disasters. This whole world is overly complex on things like climate policy, cyber policy, but disasters in its own domain is complicated. Definitely. And whether we want to reflect on 2011 Japan and how the Japanese onboarded assistance there, which was overly complicated and diplomatically challenging, or whether you want to talk about Haiti and how the first world inundated that country with all of this assistance without any bounds of the law, and completely threw caution to the wind on how we were going to help or fix the problems that many of these people have never even been to Haiti before. How do you get folks, like in the United States, we have somebody like me who lives in the Washington Beltway area. I'm not from Louisiana. I'm not from Texas. I don't live there on a day-to-day basis. I don't understand the local cultural context. And I'm expected to solve these problems from a very far distance, completely removed from those local communities.
Sure.
So where I am today is with disaster intelligence is that, those 3 goals I think are salient ones. Building a culture of preparedness. We need a culture who or that embraces disaster risk and disaster risk literacy, getting better educated and understanding the local laws as well as international law on how to deal with the complexity of a disaster that impacts the community. Secondly, readying the nation for catastrophic disaster. And we'll talk about my company and what we do to help resolve that. But, remember the Carrington event happened in 1812, right? Space weather, we didn't have the grid. We had the telegraph system maybe, but we didn't have this large machine called the U.S. National or the North American Grid. What happens when we have a space weather event that potentially fries electronics within our grid system? How do we deal with that type of catastrophe when everything from the Internet of Things to refrigeration to the cold chain in medical supply. How do we deal with the failure of a large grid outage across a massive area where, you know, millions of people in urban centers rely on air conditioning and everything else that's power dependent? So, you know, and then reducing the complexity. In order for us to have a prepared culture, we have to understand how to communicate risk better, how to be better stewards of risk, and make it simple enough where my children or my neighbor can understand how to take action, how to have a call to action and actually do something about the risk in their community. And then lastly, I'll say that, you know, because of all these laws, something that I have passion for, we talked about this, is peeling back the many layers of the onion and understanding what actually exists from a legal perspective, and how do we refine that and create a better environment in which we can enable ourselves and self-actualize during disasters so that we can solve these critical issues, because otherwise we're leaving the survivors behind, even though they're the ones that we're serving.
Definitely. Yeah, I mean, that's the background that you've just explained to us is absolutely fascinating to me, and I have just so many kind of questions that have come up, you know, just in relation to your views on certain things, because I feel like you've been in so many different areas of this mechanism. So, you know, whether it's a private sector or it's the federal government or whatever it is, and, you know, that's given you these kind of unique insights into how things overlap and then where there are gaps. And I think that is absolutely fascinating. Before we start to talk about more your kind of day-to-day with what you're doing with disaster intelligence, I just want to just track back to something that you said just now about the complexity of onboarding assistance. Say if the United States needed assistance, if there's another Katrina, if there's another, you know, Cascadia style event. The reality is, I think most of us are well aware, although some don't want to accept, but I think most of us are well aware that the US will require international assistance of some kind. You mentioned search and rescue teams, urban search and rescue teams, and the difficulties in even just getting a dog into the country. What do you think politically is stopping the conversations on that? Because we're aware that there is a need to make this process easier, to make this onboarding process easier. And I think we've got the research and we've got the data to kind of support that need. So what is it politically that's stopping us from kind of going forward and coming up with solutions to make it easier to get assistance into the United States when we need it?
I think the primary reason why this is hard, or why hasn't been resolved, is that we haven't faced it yet where the public is engaged to the point where they're asking us to solve it. You know, I think that's just true in public policy making all the time, right? You know, it's the topic du jour, the topic of the day, and then folks focus on that one shiny object, and then we go to the other. So I think the lack of political will is there because folks just don't know that this is something that's a challenge and a problem. Sure. And so when we conduct these major exercises and we build these scenarios, you know, the thing I like to say is that we love problem admiration versus problem solving. We're so enamored with the challenge of a Cascadia or a New Madrid that we're constantly like, well, this bridge is going to be out and that bridge is going to be out. Okay, well, that's almost self-evident. But what we need to do better as planners and folks within the disaster management community is understand what are the discrete issues and what are we actually trying to achieve. And if we're trying to achieve a large area, say search and rescue type of scenario, well, where is that assistance going to come from? You know, one of the interesting statistics from the Nepal earthquake in 2015 is that of all the highly technical urban search and rescue team members that came into the country from around the world, those USAR teams only saved 17 people. Wow. Whereas the local populace, the neighbors helping neighbors, so to speak, they saved tens of thousands of people because they're closest to the problem. And it takes time to get these teams in. And so by the time you onboard them, are they even necessary or effective? You know, to call up Virginia Task Force 1 well, these people have families, they have day to day, as much as they want to go to Nepal and help respond. Well, you know, it takes them time, a few weeks to mobilize. And then they finally get on the plane and they show up and they have to integrate, you know, into the, in this case, the UN cluster system. And then the UN cluster system has to, you know, figure out where to place these people and where there's the greatest need. And so this complexity of organization, I think, gets in the way. But, you know, to come full circle on your question, you know, why is it a challenge? Is because we've never had to face it here. We've never had to onboard, you know, tens of thousands or thousands of international workers into the United States to help with a large scale disaster, because these hurricanes, as horrible as they impact these communities, you know, they're regional events. They're much more focused on the immediate impact area. Whereas when we looked at the Cascadia subduction zone, we did the analysis using the Department of Energy National Laboratory modeling and simulation capabilities. Because of the impact to the bulk power system, we would have rolling blackouts, or at least some voltage collapse, east to Colorado and south to Mexico. Right. For a subduction zone incident that happened off the coast of Oregon. That's a significant amount of area. The United States has never, ever had to deal with a large scale loss of power across that type of wide area. Now, we had the 2003 blackout, but that was a couple days and it was resolved. And keep in mind, that was a tree that impacted a wire that created a cascading effect to cause the 2003 blackout, a tree.
This just shows you how vulnerable the system is. When it comes down to the day-to-day, it is such a vulnerable system. And I don't think the US is alone in that respect. It's the same in the UK where I'm from. You know, it's like you take down one power line and, you know, it's the domino effect. You know, what else is going to be then impacted straight after that?
Exactly. And so we lack the ability to provide the context for how complex and how complicated these situations are. And because we traditionally haven't been able to unpack all of that, to elevate the discrete problem sets that will need to be solved, such as onboarding international search and rescue teams. It's just one discrete problem area.
Sure.
You know? Or in Puerto Rico, the fact that we lack the visibility of understanding that there was one medical oxygen facility that supplied all of the medical oxygen to every single hospital on the island. And, you know, we had the hair on fire moment at the National Response Coordination Center where they're asking me, hey, how do I get a generator to this medical oxygen facility? I say, okay, well, what's the load requirement? You know, where is it located? Has anybody done an assessment? These things take time. It's not like we could just purchase a generator and throw it at the medical oxygen facility and it's magically going to work. So where we need to go moving forward, and this is why we're so focused on these particular issues at disaster intelligence, is how do we leverage technology and data to be able to lift up through the noise of problem admiration to parse out the individual discrete, you know, issues that we can assign a task force or assign a working group or assign a series of leaders or a group of leaders to just focus on fixing one discrete problem in blue skies. We can't be all things for all people, but we can at least try and solve some things now in blue skies. So when the thing does happen, the Cascadia, the New Madrid, the space weather event, you know, hopefully not, but, you know, an EMP from an adversary or a coordinated physical cyber attack on our infrastructures from an adversary, if one of those things happens, we don't just want to reduce the complexity when we're dealing with it. We want to mitigate the risk now so that when it does happen, it's not such an unbounded problem that it's ultimate chaos and we'll never be able to recover from it.
Absolutely, absolutely. I mean, one of the kind of themes that I'm getting from what you're saying is that we are so enveloped in these multiple levels of, or layers of the onion, to use your words. You know, there are so many layers kind of packed on top of each other that one of the things that we really need to do is just sit down and say, okay, let's figure this out. let's strip this back, let's pare it back and figure out what the core kind of issues are and what we actually need data-wise, analytics-wise, legal, all these kind of different inputs. What do we actually need to feed into this problem so that we can actually make better decisions? I mean, do you think that's a fair kind of conclusion? Are we taking all of this data and we're doing all of this sort of data analysis to be able to make better decisions?
Yeah, absolutely. That's the most, simplified way to describe what the challenge is and what we need to do about it is we have to be able to parse these things out so that we can problem solve today in blue skies and have, it's, again, to use the Eisenhower perspective, it's not the plan, it's the planning, right? Sure. And so, one of the things that I'm doing, or I'm trying to do, is get better engaged in my local community and understand how I can contribute, not just as a business owner, but just as a normal person on the earth who owns a home and, has neighbors and has a family and, day-to-day responsibilities. So next week I'm meeting with my local emergency manager. I didn't even know him until 2 weeks ago. I met him at the Florida Governor's Hurricane Conference. Yeah. And I said, "Oh, hey, you're my local emergency manager. What are we doing about, the local hazards that we face?" And so, again, I think what it requires is it's a whole of society, whole of community, I guess is the term of art that we use in the United States. And when I was working with Swedish government, that's the same term that they use, the whole of society approach. Is, it starts in the primary schools. It starts in the home front. We have to have a better sense of risk and risk literacy at an individual level so that we can better apply ourselves to these large problem sets. Because, with respect to whether it's a changing climate or whether it's a changing geopolitical world, the world is not necessarily getting safer from the threats and hazards, but we can do something about reducing the risk and being prepared to ensure that we have continuity of community. Definitely. And continuity of Main Street. Because without continuity of community, without continuity of Main Street, we're going to lose a sense of ourselves. It's going to be difficult to move on and unify ourselves in the sense of disaster. And so I believe that, not to get too overly theoretical or esoteric, but we are so immersed and focused on the day-to-day minutia of what's in front of us that we're losing sight of what's ahead. And I think that we need to, as a friend of mine said, take a strategic pause and really understand our environment so that we can come together as a community to better engage with it and make decisions that benefit the collective and the whole so that we can all benefit from these advancements in technologies and the modern conveniences and everything else, because we become so dependent and so lost in the illusion that it will be there tomorrow. It's just a false sense of reality. And I struggle with trying to communicate that. So if there's a call to action, I suppose, for myself to whomever is going to engage with this video or with this discussion, is that help me become a better communicator of risk, help make everybody understand how we can better communicate risk. Because I want to understand, how do I break it down for my two sons? Sure. Where it's difficult to just communicate to them, hey, you probably should eat this versus that. Like, that's hard enough. Yeah. How do I break down, climate hazards, and how do I break down disaster risks and communicate that at a simplified level that my 7-year-old can better understand it, and then he can take that knowledge and translate it to his friends, at basketball, or on the hockey rink, And so I think that's where I struggle, and we probably could be doing better at is understanding how do we communicate. And to me, I think some of it is simple as saying storytelling. We could become better storytellers. One of the one of the aspects of disaster management that I think we fail to capture more often is just the story of the survivor and telling that over and over again.
Yeah, it's powerful. It's very
Right?
powerful. Yeah.
Very powerful, and to use that as a way to become more engaged and more empathetic, that disasters at the end of the day affect people. And, you know, disaster management is all about people. It's not about the grid. It's not about the refrigerator. It's not about the medical oxygen facility. It's about people. And how do we reduce risk to those systems to ensure that people can continue to live another day and benefit from all this advancement that is taking us thousands of years to get to?
Yeah, absolutely. Absolutely. I mean, it tracks back all the time to that core sort of instinct of, you know, all of us, which is survival. And, you know, there's survival in the instinct, in the instant in which the threat occurs. But then there's also this kind of like, you know, pre-survival phase where, you know, we can actually do things, you know, about our chances of being able to survive an incident. So yeah, I mean, I absolutely agree with everything that you're saying in terms of where we need our priorities to be, I guess. So let's just kind of narrow this in a little bit to what you are doing with disaster intelligence, because we've talked about a lot of different kind of issues in this video already, whether it's communications or it's, you know, political kind of troubles or whatever it is. So now let's kind of narrow into what it is that you are kind of doing on a sort of day-to-day basis or a, you know, short-term basis with your company to make a difference to these problems.
Sure. So we, disaster intelligence, were just awarded Department of Homeland Security Small Business Innovation Research Award, where we will be building a power and communication system network risk assessment model or tool. It's not just about the model, but it's a platform in which we can, again, going back to what we said, peel back the layers of the onion, understand how grid systems interact with communication systems. And in fact, we're less focused on the modeling because with our partners in Argonne National Laboratory, or, you know, we're seeking a partnership with Idaho National Lab, MIT National Lab, Lincoln Laboratory, who we've been collaborating with, is that there are many models out there. And as a friend of mine said, you know, all models are wrong, some models are useful. And so the thing that we provide to that ecosystem is we've built a back-end data science platform in which we can ingest and analyze billions of records, what we like to say at the speed of thought. And so because of our partnerships with NVIDIA and with Omnisci in particular, we're leveraging the graphics processing unit and these really fast databases to parse through all of this data that we've never been able to do. In fact, a lot of the memory frameworks that we're dealing with didn't even exist over a year ago.
Wow.
These are bleeding edge new technologies that certainly the emergency management community has never engaged with. And the other great thing is it's distributed. So we're doing this, you know, using web-based tools in distributed computing environments. So you don't have to be at the supercomputer at the national lab. You know, the same GPUs that Oak Ridge National Lab is using for the Summit supercomputer are the same GPUs that we're using in a distributed environment. And so what we want to do is take these models and take the academic research and all the peer-reviewed work that has been done in these laboratories or university environment, and then translate that and transform that into operational code, into a distributed compute environment in which you and I, or the emergency manager locally, or the emergency manager or disaster manager in Japan, or in Nepal, or in Italy, it doesn't matter, that we have this environment we can leverage these models and these systems to be able to understand risk in a way that we've never been able to do ever, you know, in the past. So the idea with the DHS project is we want to build a use case in which we understand, you know, one service area. So for example, you know, just for argument's sake, let's say we take the state of Commonwealth of Virginia where I live. You know, Dominion Energy is the power provider to my home. We are served by Verizon, by AT&T, by Sprint. And so if Dominion loses power, irrespective of the hazard precipitating event, it could be space weather, it could be, a physical cyber attack, it doesn't really matter, but they lose system integrity and they can't deliver power to communication networks. How do those communication networks survive? How do they operate in an austere environment where they're dependent on power? Because keep in mind, many of the cell towers, they might have 24 hours of power, battery backup power. Some of them are run on generators, not all of them. Some of them are less than 24, maybe 4 hours, maybe 30 minutes.
Mm-hmm.
So the survivability of these individual nodes, how does that all work in concert? So what we want to do is build this integrated model to understand we could run these scenarios iteratively and then figure out, okay, if we lose power here, how does it affect communications there? And then how does that loss of communications and power impact the rest of the community?
Mm-hmm.
Or community essential functions, in the continuity sense, they call it mission essential functions. So what essential functions of the community are lost, whether it's hospitals, whether it's nursing homes, whether it's pharmacies, grocery stores, distribution centers, whatever. And then we can start to understand those cascading second, third, fourth, fifth order effects, because we believe that starting with power and communications makes a lot of sense, because almost everything, like what we're doing now, talking on this computer via the web, that's all dependent on communication systems and power.
Sure.
Without those two systems in place, none of this is possible.
Mm-hmm.
None of the modern conveniences that we enjoy are possible.
Yep.
So we're going to start there as sort of the tip of the iceberg, and then understand below the water level how power and communications impact everything else.
Yep.
And then being able to run those scenarios anywhere in the world to be able to understand that risk. So there are some assumptions being made. One assumption is that we have access to all the key data,
Mm-hmm.
which we don't today. Another assumption is that the data is not biased.
Right. I was going to ask about that. Yeah.
Right? So we need to make sure that the data that's being put into the model is unbiased, and that we can strip the bias out. That's not trivial.
Mm-hmm.
These are hard problems. I recognize that, but you got to start somewhere.
Definitely.
And secondly, we will employ, or not secondly, thirdly,
Fifthly, wherever we're at, yeah.
Wherever we're at. Third, we'll employ machine learning, deep learning applications to be able to parse out anomalies, which, that goes beyond my pay grade as far as intellectual capacity goes. But that's why we have folks like Jack on our team, who's PhD computational mathematics, former senior research scientist at Google, former professor, who will help unpack that from a technical perspective. So we got a good team, and I'm really looking forward to it. But that's just one use case. The other use case is the University of Delaware Disaster Research Center, and a number of other universities, such as Cornell, University of Oklahoma, and UNC Chapel Hill. They've built advanced researched evacuation models, which they can better identify based on the characterization of the hazard, the tropical storm, the storm surge, and so forth, which counties to evacuate first versus second versus third, and how do you build basically a tree of decisions in which the emergency manager can understand the risks and the trade-offs of whether I evacuate these counties first versus those counties, or these evacuation zones versus those evacuation zones. Because right now, it's completely arbitrary.
Sure.
It's based on the political will and whim of the local electorate. And that's important and should not be discredited. We need strong political leadership so that when the message is communicated, you need to evacuate, that it's done confidently. But how can we make it more confident? Is we take this great research and we put it into operational code, because right now local emergency managers aren't using this.
Right.
So this sort of goes to the overall thesis of the company is how do we unlock all of this research and scientific progress that's basically been behind closed doors in these laboratories and these academic environments, and pull all this into a distributed compute environment so that folks like you and me can leverage these decision-making tools and these models and this analytics to be able to make decisions where it's simplified and easy and intuitive to understand.
Yeah. That's congratulations on that. It's a fascinating project, and I think, you know, the value of it is really only going to increase and increase and increase the more we kind of get deeper into this data. So, and you know, and into these kind of decisions and these issues about like what we're actually, like where we're actually going in the next, not just 10 years, but 20 years, 30 years. It's really, really fascinating stuff. I feel, again, like we could probably talk about this all day long if we were left to our own devices. But I know you're busy, and I've got a dog that sounds like he wants to go out. So I think that's probably a great place to stop. So thank you so much. Really, thank you so much for the time that you have spent with us today. I am 100% sure that people are going to find this to be fascinating, eye-opening kind of stuff. So thank you very much.
Well, wonderful. I'm appreciative of your time, certainly. It's mutual, and thank you so much for the opportunity.
Sure.
If folks want to reach out to us, it's info, I-N-F-O, at disaster-ai.com.
Fantastic.
You can also see us at disaster-ai.com on the internet.
Yeah.
Please reach out to us. We would love to provide you access to our tools and to give us feedback, because ultimately, you know, this is to serve the communities. We're a public benefit corporation. We're looking to provide tools in which are user-friendly and meet the practitioner's needs. So the more people that we can get eyes on it and engaging with it and providing us feedback, you know, the better chance that we have to deliver tools that meet your needs and ultimately the community. So,
absolutely.
You know,
I can make sure that all of your information, all of the information about the company and email addresses, I will make sure that all of this is on there, readily accessible for anybody that wants to get in touch with you. Definitely.
Wonderful.
All right. Awesome. Well, thank you very much.
All right. Take care.